I'm going to share my screen and show a few slides as I speak. So let me do that. So I'm going to get away from a India-centric or a 10-year or a 20-year horizon and look at energy in a slightly different light. The first thing I want to say is that when I first did a course in economics a long time back, basically I was told about the factors of production being land, labor, capital. Land including, other resources and things of the sort. And of course, some add entrepreneurship. It's now that I realize that this was also wrong, and that energy, which is part of land, actually is a very utilitarian way of looking at energy. I want to look at energy very differently, not in a utilitarian manner, but what has been our relationship with energy? Why have we got into this utilitarian attitude towards energy? And what are the dangers? And how do we even try to get out of it in the first place? Okay, right. So the first thing is that what does energy do? What is energy? We don't really know what energy is. What does it do? We know that it is the mover and shaker of all processes. No energy flow and everything comes to a standstill. If you start looking at energy flows seriously, then you can explain a lot of things that happen, not just in the universe, but in human society. For example, human migration has always followed the route of where does a society get energy from? The rise and fall of empires, civilizations, all of them have followed the energy path. Now, what have we really done with energy? If we go back to 5,000 or even 10,000 years back, when we transited from being a hunter-gatherer to a primitive agriculturalist, we were using at that time basically animate energy and biomass. Okay, the difference between us and other species is basically that we have a very special ability to create the knowledge of energy conversion, and we've used it very effectively. What we've done is basically use that ability to increase the amount of energy we draw from nature. Now, today, we draw well over 50,000 times the amount of energy that we drew, say, about 10,000 years back. And that is where the problem is, growth. So what helped us get into this mode? The first thing is we convinced ourselves that we have rights which other species don't have. And that is something that we call anthropocentrism. So to give you a small example, there is a term called human appropriated net primary production. It's a big complicated term, but basically what it tells you is how much of energy that is created by photosynthesis are we taking. In 1900, it was around 13%. Today, it's about 23 to 24%. So basically what we are doing is stealing energy from other species. And that stealing has a lot of violence in it. Because when we back computed, what is the amount of energy used to deforest 1/3 of our forests as of 8,000 years ago, we discovered that actually every year of those 8,000 years, we've used energy equivalent to 20,000 Hiroshima-sized atomic weapons, atomic bombs. That's a lot of violence that we've done, okay? This is one device that we used to steal energy from nature. The second device is by privatizing nature. And there's a very simple question that we need to ask. Now, if I invest 1 joule of energy, I can get back about 20 or 30 or sometimes even 40 joules in fossil fuels. If I were to ask, what am I using that 1 joule for? Basically, it is to prospect, it is to dig, excavate, and extract, and maybe do a little bit of transport and processing. The question really is, who made that coal in the first place, or oil? And how much energy did it cost that entity to create that coal? And therefore, how do I say that by investing 1 joule, and if I get back 20 joules, that the remaining 19 are mine, that I am the owner? And when you ask this question, you suddenly find that actually the whole concept of privatization of nature or ownership really doesn't have a basis to it, neither in law nor to the best of my understanding and philosophy. Okay, so if we look at both these things, privatization of nature and anthropocentrism, both have contributed to our extracting more and more and more energy. And both these ideologies are about 5,000 years old. They're not very easy to shake off right now. And the whole concept of using energy, our attitude towards energy being utilitarian, really comes from anthropocentrism. Okay, so we have three problems. And these are serious problems because any one of these can tip society over. The first one is that fossil fuels, which today contributes to 80% of our commercial energy, mind you, there is a non-commercial energy. I'm not going to touch on that very much right now. 80% of our commercial energy, approximately, comes from fossil fuels. It's about 81 point something percent actually. Okay, now oil is going to get over in a matter of another 40 years or so, even if you count in shales. Gas a little after that, and coal is going to finish off in less than 100 years. Problem is, do we have replacements? The work that we've done so far indicates that no, not nuclear, not renewables, none of these are going to be able to replace fossil fuels fully. Nuclear, or if we don't get into things like fusion or fast breeder reactors, we just talk about thermal nuclear reactors, we have just about enough uranium ore for about 100 years if we count in the additional projects that have been proposed. And if we don't, it'll last us about 150 years. That is what the amount of uranium ore that we have. Okay. Now, other renewables have all kinds of problems, which have not yet, there are a lot of technical problems which have not yet been sorted out. For example, one of the things that people who are hunky-dory about PVs and things of the sort forget is, are the materials that are used in PVs available for how many years? And actually, if you look at some of the most basic materials, things like copper is going to exhaust out in about 40 to 50 years. And even steel, if you don't recycle it, is going out of the window in about 70 to 80 years. So you can make a PV panel. What are you going to connect it with? Silver, gold? So there are these huge other problems. Like if you go in for thin films and things of this sort, then the question arises, all right, where is the tellurium? Where is the cadmium? They're going out. So there are enormous technical problems, raw material problems with renewables, which have not yet been sorted out. For example, the materials that are used in permanent magnets in wind generators, or for that matter of fact, even in the magnets in computers, in the hard drives and things of this sort, are going to exhaust out in a short while. So these are problems which, in fact, we need to start understanding. So suddenly, after the Club of Rome report was written, we suddenly realized that there is a limit to growth, both in terms of energy as well as in terms of non-renewable ores that we have been using so far. The second problem with the overuse of fossil fuels, mind you, all the fossil fuels that we've used about 40% of it in just about 300 years, what took Mother Nature approximately 300 million years to make. So the second problem is global warming. I don't have to say very much about it. And like everyone agrees that even if the NDCs under the Paris Agreement are fully implemented, the temperature rise will be approximately 3.2 to 3.4 degrees above what it was before the Industrial Revolution. All right, that temperature rise has been brought down a little bit after China has recently put out its new policy. But certainly, we have researchers saying that it is not going to be between 3 and 4, it's going to be much higher. It's probably going to be above 5 or even maybe 6 degrees. We don't know yet where exactly the thing is. The third problem is how do we distribute this energy? And basically what we've done ever since we've privatized nature is we have distributed it inequitably across countries and within countries. Within countries, of course, the difference is much, much larger, particularly in countries like Brazil or even India, for that matter of fact. But across countries, again, there is a massive difference in terms of the per capita energy consumption that you have. For example, the global average energy consumption is approximately 2 tons of oil equivalent, whereas in India it's 0.7 or 0.72 to be a little more precise, and Afghanistan is 0.09. The high income countries are 4.6, and the low and middle income countries, it's 1.3. So massive differences are there. And this leads to conflict and it leads to war, which is exactly what has happened in the last couple of centuries. Okay, so we have these 3 problems. Now, the question is not to just talk about problems, but how do we start fixing them? So we need to ask ourselves before we, come up with fixes or, we start discussing fixes, we need to ask ourselves 3 critical questions. How much energy can we take from nature and call ourselves sustainable? Now, that's a very dicey question because it all depends on how we define what is environmental injury. Somebody may say environmental injury is, up there. Someone may say it's down here. Or the argument goes on and on. And so we require something called a sustainability index. We need to really discuss this a lot more than what we are doing right now. And we need to quantify some of these things because even though, we tried to define what is sustainable development maybe 35 years back, that's what Gro Brundtland did, we went just exactly in the opposite direction. We just became far more unsustainable in the last 35 years than in the 135 years before that. So we need to quantify what is sustainable. So we need a sustainability index. And some of us have been working on some of these issues and also discussing and debating these issues both within this country as well as outside the country. The second problem is where will our future energy come from? And the third is how do we distribute this energy? Okay. Having said that, to me, the answer lies from whatever work I have been doing along with other friends, is the answer lies in doing 2 things. As a global program, we need to reduce our energy consumption by about half of what we are using right now, which is about 14 gigatons of oil equivalent commercial energy. And there's another 4 to 4.5 gigatons of oil equivalent which we are using, which is non-commercial energy, which means basically sunlight or cow dung or biomass, which doesn't enter the market at all. Okay. Much of it is actually sunlight. Okay. The second is quite obviously, since I have said that I don't see a rationale for ownership, we say that we distribute energy equitably right across, actually equally. But some regions may require more energy, some regions may, agree to forego. So we can arrive at an agreement that somebody in Sweden may require a little more energy, somebody in India may require, India may require a little less energy. So it's by agreement that we decide, all right, we will distribute the energy equitably. Fair enough, okay. But what are central to these issues is that we will have to change our understanding of what is our relationship with nature itself. Are we part of it or are we apart from it? Is nature something that we use, or is nature something that we are part of and use it to the extent that we need it? Need being the word that I would underline, need to look at what other species do, which is they do risk minimization. They don't do gain maximization for a few. There's something to learn from other species. Okay, having said that, now let me do some, as they say in Hindi, khayali pulao. Okay. Now, if I want to power down, I can do it even without getting into renewables. If I adopt three measures. The question is, who will allow me to adopt these three measures? Nobody will, actually. Not unless the whole world gets onto the same page. And what are those three measures? Each one of these measures actually can reduce 8 to 10% of our current energy consumption of 14 gigatons of oil equivalent. One is to shrink cities by half or whatever, approximately. The second is to get rid of air transport and private surface transport, which means cars, private cars, and private boats. Okay. And the third is to move towards soft borders globally. Okay. So these three measures, in fact, immediately will bring us down from 14 to approximately 10, after which we'll have to look for other solutions. But the point is, politically, how do you do this? How do you do this? I don't have an answer really to this question. Okay, so when we talk about energy equity, now our global per capita energy consumption is approximately 2 tons of oil equivalent, right? For our calculations, sustainable per capita energy consumption would be approximately half that, about 0.91 ton of oil equivalent per person per year on current population, mind you. Okay. Now, is 1 ton of oil equivalent adequate? The answer is yes. On 1 ton of oil equivalent, a family, it's not for a family, but I'm saying on 4 tons of, if we take a family of 4 tons of oil equivalent, and a family can live a reasonably middle class life. They will not be able to own a car or a scooter, but they can have many of the other goodies that they have today. Okay. Now, supposing we were to say, let us power down as well as get into an energy equity regime, what does that imply? If everybody in the world were to come down to approximately 1 ton of oil equivalent, it means that the US has to reduce by 90%, and Europe, Australia, Japan, New Zealand will have to reduce their energy consumption by 75%, so that India, for example, can move up from about 0.7 to approximately 0.9. 15 to 20% more, or a little more, 25% more. India can still go up a wee bit. Yeah. Politically, how do we do this? Can't be done. Not under the present dispensation. Okay, no one's going to agree to this kind of a solution. Not until we get everybody onto the same page. And that is where the problem is. How do we get everybody onto the same page? Okay, but the point is that we have so far been seeking solutions without getting everybody onto the same page. The question arises, so are these solutions really what one would call energy and climate justice? To me, obviously they are not. Okay, so do we accept these solutions, or do we work out a different regime of solutions? The problem is, even if we want to get everybody onto the same page, if you take a country can decide to increase its energy consumption, and it can decide so on its own, and it can probably even implement it. The problem is, it cannot solve the problem. No country can solve the problem of these three tipping points. One is that of resource exhaustion. The second is of climate change. The third is of inequality. No country can today solve these three problems on their own. Not until all the people of the world, all the countries or people of the world get onto the same page. The whole point is how. If you look at what has been happening, for example, in the COP agreements, quite obviously there is a lot of squabble going on, and ultimately, as resources shrink, what every political leader of every hue and cry, by and large, is going to say is, I am going to solve the problem for my country the way I believe I ought to. And this is exactly what you see happening around in the world. And every leader is basically going to turn more nationalistic and therefore move away from a collective solution of this problem. And therefore, my contention is quite clearly that the current political formations cannot really deal with these problems. And you require an entirely different political dispensation really to solve these problems. Where will it come from? Well, we'll deal with that maybe a little later. So while I have said that these problems cannot be solved locally or nationally. Do we do away with local solutions or national solutions? I say absolutely not, because one of the statements I made was that unless there is a push from people and every country to get onto the same page, it won't happen. Now, how will people get onto the same page? Only by doing whatever they can locally and thereby gain the credibility to push for a global solution. And therefore, at a local level, doing things becomes extremely important. But just by doing local things will not give us a global solution. So locally, what do we need to do? We need to push for these two programs. Do any program which will reduce carbon and energy consumption and which will increase equity. So it could be recycling, it could be rainwater harvesting, it could be organic farming, whatever it be. There are a host of things that people are doing all over in this country and outside this country, and which has been excellent work has happened all over. But a single experiment like Pastapur or Hivre Bazaar doesn't duplicate. The neighboring village doesn't do it, because the power of privatization of nature is so great that the next village is not willing to adopt what Hivre Bazaar or Ralegaon Siddhi have done. This is the dilemma of the whole situation. At a national level, what is it that we need to do? We certainly need to push for net carbon neutrality by 2030 in the northern nations and 2040 in the southern nations. We need to taper down expansion of carbon and hydrocarbon industries. We need a sustainability index. We need to make the carbon and energy audits mandatory. And what I would say is we need to start moving towards biomass. And a very interesting example is our neighboring country, Sri Lanka. Sri Lanka uses half the per capita energy that we use. And yet they're 60 ranks, more than 60 ranks above India in terms of Human Development Index. Now, I wrote a piece on this some time back, but the centrality of it is when you look at their energy mixes, basically, India's energy mix tells us that our energy consumption is dependent on fossil fuel to the extent of 75%, whereas Sri Lanka is a little less than 50%. Their urbanization is less than ours, and it is urban areas which are actually the guzzlers of energy. They are far more dependent on biomass than we are, a energy source which is actually far more egalitarian because it's ubiquitous, it requires less investment, local people use it. And in terms of what is called a well-to-wheel efficiency thermodynamically, it is more efficient actually than fossil fuels because there are less energy conversions from the time you actually harvest biomass to the time you use it. So there's a very interesting example in what Sri Lanka has done. And yet we have many challenges in front of us in these energy transitions. I've already touched on a wee bit on the technology challenges. That is that, getting into renewables is not automatic. And there is actually an energy cost, in fact, into getting into renewables itself, which including things like hydrogen and so on. And hydrogen is not a very good idea at all because it's what is called energy return on energy invested is only 0.2 to 0.25, which means actually you get less energy out of it than you put in order to make hydrogen. So unless you make hydrogen using solar energy, you are actually ending up something similar to what Vandana talked about a little earlier, which is you're going to put in more energy and get less energy, like the American agricultural sector. So it doesn't make sense to get into hydrogen unless you're able to tap solar energy. And so getting into solar itself in the short run is okay, but in the longer run, there are problems with solar. Okay. The second is in the whole sustainability debate, there is a discussion that goes on something called restoration versus restitution. Can you really restore the environment to what it was? Never can, because how can you get those species back that have disappeared, that have gone extinct. You can't. So what really is the meaning of restitution? And where do we peg it at? So these are still debates that are being done. And the last word on this has not been written or spoken. The third problem is if we talk about equity, we've talked about equity within this generation, we've talked about equity between generations, and there are some people now for the last 20, 30 years who are talking about equity between generations, between species. Not a concept which is very new, not in India, because if you go back and look at the non-Abrahamic religions, then there is some discussion, in fact, on this whole subject, both in Hinduism as well as Buddhism. What is the relationship of humans with nature? These are things which have been debated and are still being debated. The question I ask is that if we even start talking about equity between species, what happens to theory of value? It disappears, basically, and we'll have to redefine value. And that is a task that, some people are doing. The next problem is that there is a difference between a thermodynamic equation and an economic equation, and they are both out of sync. And the best example to provide is the example of agriculture in India. Now, there is in a thermodynamic equation, the energy input has to be equal to the energy output because you can't destroy energy. So basically, whatever goes in on the left-hand side is equal to whatever comes out on the right-hand side. In an economic equation for the same process, this is not so, because what happens in an economic equation is basically sunlight which comes in as energy free of energy cost is not valued. The very substance actually towards which, the very energy source towards which we need to move to become sustainable is not valued by economics. And so economics today, as we understand it, as we practice it, without going into ecological economics and things of this sort, is highly anthropocentric. Now, with this economics, can we really sort out problems in the long run? I don't think so. Anyway, the next problem is there is a very high correlation between growth of knowledge and growth of energy consumption. If I had the time, I would have, put out graphs and things like this, some of which we've developed ourselves, some of which, others have developed. But actually, when you look at history is really both of nature as well as of human society, is really the history of energy conversion. And all of us are nothing but big players in the whole process. Okay. Now, without expanding on that very much, there is a very high correlation between the growth in knowledge and the growth of energy consumption. Now, what do we do with knowledge? Do we say that any knowledge is okay? Or do we say that we voluntarily start eschewing such knowledge which increases entropy rapidly, and we try to create such knowledge which actually reduces the rate at which entropy growth happens? So the situation is, if you look at the Earth, the only piece of rock that we know where life has happened, life has, as a system, reduced entropy. But does that mean that the second law of thermodynamics is violated? No, because entropy in the system as a whole actually is increasing. But in a small portion of the system, entropy has decreased. So in a sense, what humans have done is acted against the other species altogether. And when you look at this in terms of more recent work, that is energy densities and complexity issues. Now, energy density keeps on increasing, which is, I'm going to show this slide very briefly, keeps on increasing as complexity increases. So finally, the question that arises is, where are we as a human society going with the attitude we have towards energy today. Thank you very much.